Beneath the ocean's depths, a revolutionary military predator has emerged. Resembling the silhouette of a great white stingray, the manta ray is far from being a natural aquatic entity. Instead, it represents the pinnacle of underwater drone technology, a highly advanced unmanned underwater vehicle designed to execute a variety of long-range missions. These include reconnaissance, intelligence gathering, and even offensive operations, all with minimal human intervention. While much about this groundbreaking drone remains classified, the available information offers a glimpse into a transformative leap in submarine warfare. In this video, we delve into the manta ray's technological marvels, operational strategies, and its potential to redefine military tactics in future conflicts. Background and development. In February 2020, the United States Department of Defense announced funding allocations for various advanced military projects, including a $12 million investment in the Defense Advanced Research Projects Agency. Defense Advanced Research Projects Agency, renowned for pioneering cutting-edge defense technologies, was tasked with developing an unmanned underwater vehicle capable of high operational autonomy over extended distances. This initiative aimed to enhance the U.S. Navy's underwater capabilities, addressing emerging maritime threats and expanding surveillance operations. Key contractors involved in this ambitious project included industry leaders such as Northrop Grumman, Metron, and PACM Technologies, with Northrop Grumman assuming a leading role. The Manta Ray program sought to create a drone capable of performing both surveillance and combat operations, an endeavor that garnered significant interest within the military community due to its potential to revolutionize underwater warfare. Defining the Manta Ray. Categories and features. The Manta Ray is classified as an autonomous underwater vehicle, a subset of unmanned underwater vehicle designed to operate independently without direct human control. Unlike remotely operated vehicles that require continuous human oversight, autonomous underwater vehicles like the Manta Ray follow pre-programmed instructions or utilize artificial intelligence to make real-time decisions. This autonomy enables them to navigate complex underwater environments and execute missions with unparalleled precision. Key features of the Manta Ray include high autonomy, allowing for long-duration missions without human oversight. Advanced navigation systems equipped to maneuver through challenging underwater terrains. Stealth capabilities designed to minimize detection. And combat readiness, with the potential to be armed to counter underwater threats. These attributes position the Manta Ray as a versatile asset in modern naval operations. Technological challenges and innovations. Energy efficiency. Large military submarines often rely on nuclear power to sustain prolonged missions. However, adapting such a system to a drone's compact size is complex. To address this, Defense Advanced Research Projects Agency has explored alternative energy solutions, including thermal energy conversion, which utilizes temperature differences between surface and deep waters to generate power, and blue energy, reverse electrodialysis, which harnesses voltage from salinity differences in seawater. These systems enable the Manta Ray to recharge its energy reserves while stationed on the seabed, facilitating extended missions without frequent resurfacing. Structural resilience. Operating in the ocean's depths requires resistance to extreme pressures and corrosion from saltwater. The Manta Ray's robust design ensures it can withstand such harsh conditions while maintaining operational integrity. Materials and construction techniques have been carefully selected to enhance durability, allowing the drone to perform reliably in diverse and challenging underwater environments. Stealth design. Inspired by its namesake, the Manta Ray, the drone's shape allows it to glide underwater efficiently, minimizing energy consumption and detection. Its flat, delta-shaped wings and vertical tail fin enhance its stealth and mobility. However, visible welds and joints on early prototypes suggest ongoing refinements to achieve optimal invisibility. These design considerations are crucial for conducting covert operations and evading detection by adversaries. The role of artificial intelligence. A standout feature of the Manta Ray is its reliance on artificial intelligence for navigation and decision-making. Unlike conventional systems that require constant human oversight, the drone can autonomously plan routes, avoid obstacles, and adapt to changing mission parameters. This capability makes it a formidable asset for reconnaissance and combat in hostile waters. The integration of AI enables the Manta Ray to perform complex tasks with high precision, enhancing its effectiveness in dynamic and unpredictable underwater environments. Operational milestones. On April 8, 2024, Northrop Grumman took a major step forward in the development of the Manta Ray by unveiling its first full-scale prototype. This marked a pivotal moment in the program's evolution, transitioning from conceptual design to practical application. Rigorous testing was conducted off the coast of Southern California to evaluate the drone's performance under real-world conditions. The tests focused on validating several critical aspects, including the drone's modular design, which allows for rapid assembly and deployment, making it highly adaptable for missions requiring swift mobilization. The stealth tests demonstrated the Manta Ray's ability to operate discreetly in various underwater environments, showcasing its potential to evade detection by enemy forces. Additionally, its energy-efficient propulsion system and innovative energy harvesting capabilities were rigorously evaluated, proving the drone's capacity to sustain long-term operations without frequent refueling. While exact specifications, such as operational depth and payload capacity, remain classified, reports from local observers, including fishermen in Hawaii, suggest a wingspan of approximately 10 meters. This size not only underscores the drone's significant capabilities, but also hints at its ability to carry a diverse range of equipment and armaments, positioning it as a game-changer in underwater operations. Potential military applications. Once fully operational, the Manta Ray is poised to transform the dynamics of submarine warfare with its advanced capabilities. The drone's ability to carry various payloads, including torpedoes, mines, or bombs, makes it an invaluable asset for offensive underwater operations. Its stealth design and advanced propulsion systems enable it to infiltrate hostile territories undetected, creating opportunities for strategic strikes or surveillance. Equipped with cutting-edge sensors and artificial intelligence, the Manta Ray can conduct detailed mapping of enemy-controlled waters, providing critical intelligence to naval commanders. Its energy-efficient design ensures it can patrol expansive areas for extended durations, making it ideal for monitoring activities in regions like the Pacific and South China Sea, where geopolitical tensions are intensifying. Analysts predict that as adversaries such as China and Russia continue to develop their own underwater technologies, platforms like the Manta Ray will be instrumental in maintaining the United States' maritime dominance. Furthermore, its autonomous capabilities reduce the need for large human crews, freeing up resources and minimizing risks during high-stakes missions. The Manta Ray's versatility positions it as not just a defensive tool, but a proactive force in modern naval warfare, capable of adapting to a wide range of scenarios. Civilian uses and future prospects. While military applications are at the forefront of the Manta Ray's development, the technology offers immense potential for civilian use. For instance, its advanced mapping capabilities could be employed to explore uncharted ocean floors, contributing to scientific research and the discovery of underwater ecosystems. Its ability to monitor marine life and track ocean currents could aid in environmental studies, offering insights into climate change and the health of aquatic habitats. In disaster response scenarios, the Manta Ray could be used to survey submerged areas after tsunamis or hurricanes, identifying risks and assisting rescue operations. Despite these civilian applications, the primary goal of the Manta Ray remains enhancing the strategic advantage of the U.S. Navy. Northrop Grumman has emphasized the transformative nature of this technology, drawing parallels to the impact of aerial drones in modern warfare. With its autonomous features, extended operational range, and multi-mission versatility, the Manta Ray is set to become a cornerstone of both military strategy and civilian innovation. Its dual-use potential ensures that this revolutionary drone will play a critical role in shaping the future of underwater exploration and defense. And that wraps up our deep dive into the revolutionary Manta Ray underwater drone. If you found this video fascinating, and make sure to give this video a thumbs up and hit the subscribe button. Let us know your thoughts in the comments below. What excites you most about the future of underwater technology? Thanks for watching, and we'll see you in the next one.